Cholesterol is transported through the bloodstream by carriers including low-density lipoprotein particles, or LDL. High LDL levels, and thus high levels of cholesterol, are a major risk factor for the development of atherosclerosis and cardiovascular disease. As part of LDL's natural catabolism, it is taken up by LDL receptors found primarily in the liver. Here, LDL can bind to the LDL receptor on the surface of hepatocytes within the liver, where it is internalized and cleared from the circulation. The LDL receptor can then be recycled back to the cell surface, where it can bind to further LDL. Proprotein convertase subtilisin kexin type 9, or PCSK9, is a key regulator of LDL receptor presence on the surface of hepatocytes. Circulating PCSK9 binds to LDL receptors with high affinity. When circulating LDL binds to the LDL receptor PCSK9, the complex undergoes endocytosis into a clathrin-coated vesicle in the hepatocyte. However, with PCSK9 bound to the LDL receptor, the entire complex is targeted for lysosomal degradation, preventing the LDL receptor from being recycled back to the cell surface. Therefore, the level of circulating PCSK9 influences the density of surface LDL receptors and correlates with clearance of circulating LDL-C. Thus, fewer LDL receptors are available on the liver cell surface to bind circulating LDL-C, and circulating LDL-C levels rise. Research has shown that patients can have different mutations within PCSK9, which can alter PCSK9 function, thereby impacting circulating LDL-C levels. Some such mutations are associated with autosomal dominant hypercholesterolemia, ADH, characterized by lifelong elevation of LDL-C levels, early development of atherosclerosis, and increased risk of cardiovascular events. Gain-of-function (GOF) mutations within PCSK9 allow PCSK9 to function and interact with the LDL receptor better, lowering LDL receptor expression to the degree that a form of familial hypercholesterolemia can develop, and can increase levels of circulating LDL-C, increasing the risk of cardiovascular complications. Conversely, loss-of-function (LOF) mutations within PCSK9 decrease PCSK9 function, compromising its ability to interact with the LDL receptor, thereby increasing LDL receptor expression. As a result, such mutations can decrease LDL-C levels and reduce cardiovascular risk. As LDL-C has been shown to be a strong independent risk factor for atherosclerotic events, PCSK9 function can affect LDL-C levels. Sanofi and Regeneron are conducting research into the role of PCSK9 in LDL-C metabolism.